We're on the Math 4 exam review, problem 22. And for A, they're asking us to perform each operation and simplify and write our answer in complex number form, which means A plus BI form. And I want to remind you that you can check your work in your calculator on this. Be sure your calculator is in the correct mode. But on the exam, I will want to see your work. So I want to see your steps. But you can always check the work. Okay, so I'm adding two complex numbers. Remember, the rule is add the real number part and then add the complex number part. So when I add the real number part, I have 7 plus 3. And when I add the complex number part, I have 7i minus 6i. 7 plus 3 is 10. 7i minus 6i is I. And that's your final answer. Remember, it needs to be in the correct form, which is A plus BI form. It says that right up here. So that means real number part first and imaginary number part second. Excuse me. When I move on to this one, I'm subtracting, so I have to remember to change both of those signs. So that's 7 plus 5i plus 4, minus a negative is plus 4, minus negative I is plus I. So now I'm going to add my real number part. 7 plus 4 is 11. And 5i plus I for the imaginary number part is plus 6i. It's in the correct form, and that's all they're asking for. Okay, on C, I have to distribute 3i to the things inside the parentheses, so I have 3i times 9, which is 27i, and then 3i times negative 8i, which is minus 24i squared. So this certainly does not look like this form, so I have to figure out what to do with that. 27i is probably going to come over to the right, and I have to look at negative 24i squared. Remember, I squared is equal to negative 1. The only thing the I squared does to this term is change the sign. So now I have 27i plus 24. Still not in A plus BI form. All I have to do is change the order of these. So I have 24 plus 27i, which is now in the correct form. Okay, we're continuing with more of the same. Remember, the instruction said perform each operation and simplify and write your answers in A plus BI form. So for D, I have a fraction with 7 minus 6i in the denominator, which means I have a fraction with a radical in the denominator, which is not allowed. Remember, I stands for the square root of negative 1, so I'm not allowed to have that I in the denominator. So the rule is multiply by the conjugate of the denominator. That's the same thing we did when we were trying to get radical signs out of the denominator earlier. We multiplied by the conjugate of the denominator. Since I does have a radical, I'm going to do exactly the same thing. Multiply by the conjugate. The conjugate is exactly the same numbers with the sign changed. And I'm going to multiply both the numerator and denominator by that, because of course only thing I can multiply by that will not change the value of my fraction is 1, and something over itself is 1. So in my numerator, I'm just going to FOIL. 7 times 7 is 49. Outer, 7 times 6i is plus 42i. Inner, negative I times 7 is minus 7i. And last, negative I times 6i is minus 6i squared. There's my numerator. And now, if you remember from the previous problems we did where we were multiplying by conjugates, I said all you have to do is multiply the first and the last of FOIL, not the O and the I, because the O and the I cancel. So let's look at O for a second. Outer is 7 times 6i, that's 42i. Inner is negative 6i times 7, that's negative 42i. Those cancel each other out. So all I have to do is first, 7 times 7 is 49. And last, negative 6i times positive 6i is minus 36i squared. So let's collect up what we can on the top. In my numerator, I have 49. 42i minus 7i gives me 35i. Just collecting my like terms there. And minus 6i squared, remember I squared is negative 1. Negative 6 times negative 1 is positive 6. It changes the sign of the number in front of it. So the same thing's going to happen here. Minus 36i squared becomes plus 36, and I have 49 plus 36. So now let's collect those. My numerator, 49 plus 6 is 55, plus 35i, and 49 plus 36 is 85. So I want to see if there's any reducing I can do, and I can look at all of those since they end in 5 and see that they're all divisible by 5. So I want to do that. That gives me 11 plus 7i over 17, because 85 divided by 5 is 17. And that's my final answer. Now, if you're doing that in your calculator, your answer would look like 11 over 17 plus 7 over 17, and the I would be at the end of it, but it would look like it was in the denominator. So if you're checking your work in your calculator, just be really careful that you can recognize what it looks like, because they use that side, that diagonal fraction bar, and when they do that, it sort of looks like 7 over 17i. It's hard to recognize that the I is not in the denominator. So be careful to do it by hand. Check your work in your calculator, but recognize that that I is not in the denominator of that. So of course we don't want that as part of the answer. Okay, moving on to E, I am foiling two binomials. So that's a very simple process. 7 times 8 is 56. Outer 7 times I is plus 7i. Inner 8i times 8 is plus 64i. And last 8i times I is plus 8i squared. So that gives me 56 plus 64 and 7 is 71i, and plus 8i squared is minus 8. 56 minus 8 is 48, plus 71i.